In this video, we're going to be looking at a few other folders in the parts database, as well as how to actually copy files that you download from the parts database into your final inventor file. So first, let's look at the gears folder. Let's double click on that. And here's where a little knowledge of gears is required. So, as you should know, the diametric pitch of a gear is the number of teeth of that gear divided by the diameter of the gear. In other words, it is a ratio that quantifies how many teeth there are per given a certain diameter. So gears with a larger diametric pitch are going to have more teeth given a certain diameter than ones with smaller diametric pitches. So we've created two folders, ones with gears that have larger diametric pitches, and large is a relative term, but larger than the ones with the small diametric pitches in the small folder. And the reason we've done this is because creating gears in Inventor is a complex process, and we hope that within these two folders you'll find everything to fulfill the needs of your robot. So let's go inside you can talk to a technical advisor or Professor Purwar. Alright, but let's go into the large diametric pitch folder. Okay. So within this folder, there are three different types of files: PDF files, IBT files, and DWG files, just like any other thing in the parts database. Three different files. And all of them are labeled correspondingly. Now, you'll notice that there's a certain pattern to how all these are named. They start with an integer, then within parentheses there's D, and then another number. And some of them have words after them, like circle shaft, DC motor shaft, circle shaft, and some of them are just blank. The number inside the parentheses, let's start with that. That number is the diameter of the gear. Whether the label after it, whether it is blank, circle shaft, DC motor shaft, servo shaft, these are labels that are the same exact labels that you saw on the wheels. So if there's no label, if it's blank, it's just a blank gear with no hole in the middle. If it's circle shaft, it has the shaft of 0.16 size hole in the middle, and that fits your number 6 screws loosely, number 8 screws nice and tight, and your blue Vex hinges that you'll be getting. Well, DC motor shafts gears have the DC motor shaft hole, and servo shafts have the servo hole. And that applies to every gear here you see. So gears with a diameter of 2.75 have the circle shaft option as well as the DC motor shaft option. Same goes for diameter 3.438. The last thing we need to address is these numbers up front. Now you should notice that there are only gears with three different diameters: 1.1375, 2.750, and 3.438. And if you want gears with different diameters, we can go into that. We're going to go into that shortly. But first, right now in this folder, there are only three different gear sizes. And you may notice that 2.750 is twice as large as 1.1375. Hence, the number preceding the diameter is 2, where this is 1. In other words, the first number in this column is the gearing ratio. So this is 1. This is a twice as large gear. This is a gear that's 2.5 times as large. And from that gearing ratio, you can design gear trains to transfer velocity or torque as desired. So let's open one of these up and see what it looks like. So here's a circular shaft gear. We can enter this sketch. We can see this is the gear, this is the circular shaft. Now, we would have liked to fix these teeth so you cannot edit them. It prevents accidental mistakes. Unfortunately, doing so requires a lot of processing power and can stall or even crash Inventor at times. And I know it's not the ideal situation, but we've, for at least for the time being, left these unconstrained, which means if you wanted to edit these teeth, you could, So be careful, don't edit the teeth shape or your gears might not run as smoothly as they would otherwise. But as long as you're careful, this should work fine. And you can use this gear in your robot design and request it as one of the parts you'd like us to print. But now, how do we get this part over into our Mech 101 template folder, or the folder file, excuse me? Or, in other words, how do we get this into the file that you're designing your robot in? Well, we just highlight the part, press Control C, click on your file that you're working in, and use Control V to paste. And you can see now it's down here in the bottom left corner. If you don't like it there, you just move it around with the move tool. Okay, you can move it to a different part. If you don't want it to paste there, let me give you a little logic of why Inventor decided to put it there. So let's put this back. We notice that from the origin to the center of this gear, it is a line of 1.282 at 38.75 degrees. Going into our original parts database file, we see that from the origin to the center is the same exact line, 1.282, at an angle of 38.75 degrees. So what that means is Inventor copies and pastes with the origin as a base point. So if you wanted to copy and paste it into a different location into your new file, select the Move button in the Parts Database file, move it to a different point, maybe like all the way up here. Again, I'm in the Parts Database file right now. I can copy, go over to my file I'm working in, Control V for paste, and you can see it pastes it in a different spot. Same place with respect to the origin as our original file. That's how you copy and paste. And then once it's in your Mech 101 file, you can edit it and change it however you want it. Again, I wouldn't change the teeth size. You probably don't want to be changing this 0.16 size if that's the gear you selected, because this 0.16 is perfectly fitted for number 8 screws and the Blue Vex hinges, and it fits the number 6 pretty nicely as well. But if you wanted to do something, you absolutely could. Going back to the parts database, if you wanted to have a gear train with a gear ratio of 2, you could just select another gear with gear ratio 2, and you can see it's larger now. And you could copy it, go to your file, Control V for paste, and there it is. And you can see why pasting in a different spot might be nice. If you already have something there, it's kind of difficult to select and move, especially when things overlap like this. And like I said, you want to be really careful not to edit this teeth geometry. If you have doubts that you may have edited it, I think it's always best to press Control Z, go back, and make sure you didn't edit it. So that's pretty much it, but you might be on gears, but you might be wondering, okay, well, what if I don't want a gear that has a diameter of, or a radius of 1.295 inches? What if that's not what I want? What if I want one of only 1 inches? Well, you can scale these gears, just like you'd scale any other geometry. Just click yes. And maybe we can scale it a factor of 0.5. Now we have a smaller gear. But here's something that's really important. And if you understand this, it means you have a good intuition of what diametric pitch means. When we scaled this gear, we decreased the diameter, but we kept the number of teeth the same. What that means is we have the same amount of teeth and for a smaller diameter. So we have a higher ratio of teeth per diameter. Our pitch radius has now increased when we shrunk this. As a result, this gear will not mesh with either of these other gears that we selected from that same file, because the pitch rate, because the diametric pitch is no longer the same. And in order for gears to work together, their diametric pitch needs to be the same. So if you wanted these gears to mesh with this, you'd have to also scale them down to size. So if I wanted a gear that meshed with this, that had a gear ratio of 2, I couldn't use this gear that I've already brought in, because it has different diametric pitch. It wouldn't even have the ratio of the radiuses is not even 2 anymore. It's 4. But it doesn't, you can't even use this for a 4-to-1 gear ratio because they won't mesh because they don't have the same diametric pitch. So if you want a gear ratio of 2, you're going to have to go back to the parts database file that you downloaded, select the gear. I'm just going to move it to a different spot so I can bring it in at a nice clean location. Okay. Copy. Paste. Oops. Paste. Now I have this gear, and I should scale this down by the same factor, the exact same factor as I scaled this other gear, 0.5. And now these gears are smaller, and they will mesh. Okay? So we did all that work in the large diametric pitch folder. The small diametric pitch folder is exactly the same. The only difference is you actually have a gear ratio of 4 option available to you, whereas in the large diametric pitch, the gear ratios only go up to 2.5. Now, what are the benefits and advantages of using a large or a small? Well, as you saw, the smaller diametric pitch allows you to have a larger range of gear ratios. But the larger diametric pitch gears tend to mesh nicer. So if you can go with a large diametric pitch, we recommend that you do that. Alright, so that's gears. So just one last thing to remember. Really just want to drive the point home. Gears need the same diametric pitch in order to work with one another. So gears in the large diametric pitch folder will not work with gears in the small diametric pitch folder. They're incompatible. You can only mesh with gears within the same pitch folder. You can scale those gears in that folder and mesh them together, but only if they are scaled by the same factor. Hope that's clear. Post on Piazza if you have any questions.